Well, hello everybody. Sorry you missed day 4 of our chapter 8 in FST. Here's what I need to do with you today. I need to continue to build on our day 3 class where we talked about arithmetic sequences and series and geometric series. Our focus today being on a geometric series that goes on forever. What happens then? But if you were in class today, Miss Dina Hand, we would have answered questions today. You did miss a quiz, so you need to make sure you get that caught up ASAP. And then I need to cover section 8-7 with you. Kind of on a scary note, this is our last section in chapter 8. So we got a review sheet coming up and we got a test coming up. Not even called a test, called a grade-raising opportunity. The things that you'll need in front of you today, you will need to make sure that you have your day 4 notes in front of you. That way you can follow along. You'll definitely need your calculator. I'm going to show you something pretty cool on your calculator that you've never seen before here towards the end. Otherwise, we'll start right here. So if you would, come over to right there. This is not on your worksheet, but hang with me for a second and let me talk you through this. Here's what you're seeing in front of you. I've come up with a geometric series that goes 100 plus 50 plus 25 plus 12.5. Notice that every time I'm taking half of the previous term. So R is going to be 1/2. Guys, here's what I'd like to do with this. I would like to add this series up, not for the first 5 terms, not for the first 10 terms, but forever. Sounds kind of scary. Sounds like we'll be here for a long, long time. That's really not the case. Guys, look at this little spreadsheet that I made up for you. I've listed the first 16 terms, and I put them as decimals because that was easier for me. The first term was 100. The second term's 50. The third term's 25. And then kind of look what it does. 12.5, 6 1/4, 3 1/8, 1.5625. Notice what happens, guys. My decimals get smaller and smaller and smaller. One thing that you'll realize, that when your R value is less than 1, when your R value, absolute value, is less than 1, because that way you can't use a negative, all that happens to the numbers as you add them up, the number of decimals continues, but the number itself really doesn't grow. Look at my third column here. My first number was 100, so bam, I'm already at 100. My next number was 50. If I add 50, I'm up to 150. Then I added 25. Then I added 12.5. Heck, after 5 terms, I'm already up to 193.75. Then I'm up to 196.875. But guys, look what happens. I really quit growing. There's a shortcut to get the answer that would show up if you did this forever. You could probably guess, maybe, looking at my spreadsheet, what this sum comes out to be. Notice that it looks like just more decimals are showing up. If we did this forever, guys, I would get a sum of 200. Here's a little formula that would have told you that. If you can look at your sequence and get the value of the first term and get the value of your R, there's a formula that would allow you to sum up a set of numbers in a geometric series as long as your absolute value of your R is less than 1. And that's simply your first term over 1 minus R. So check this out. G sub 1 is 100. 1 minus R, my R value happens to be 1/2. 1 minus 1/2 is 1/2. I don't want that showing up. And I'm back. My R value is 1/100, so I got 100 over 1/2. If you run that through your brain or your calculator, I'm going to get 200. Notice that's where I was going. So I can say this, the sum, as we sum this up to infinity, is going to be 200. Sometimes we'll say the limit as we approach infinity is going to be that sum. But I'll use S sub infinity the most. So if you would, come over to your first example there. What we got to do is this before we can use this formula. I need to make sure that it's geometric, and I need to make sure that it's a series. Well, the series part's easy. I see plus sign, so I know it's a series. I need to make sure it's geometric. I'm going to show you two ways. The fastest way is looking at it and see if you can determine. To go from 5/3 to 5/9, it looks like I need to multiply by 1/3. So I'm going to ask myself, does 5/3 times 1/3 get me to 5/9? The answer, of course, is yes. If I multiply by 1/3 again, do I get to 5/27? Yep, and the answer is right. Guys, here's another way. This is a little longer, but I'll show you both ways, and throughout the lesson we'll just use it. I'm going to take my second term divided by my first term, and if I do that, I'm going to have 5/9 divided by 5/3, which really becomes 5/9 times 3/5. Well, those cancel out, leaving me 3/9, which is 1/3. Now I'm also going to check g sub 3 divided by g sub 2. So I'm going to take 5/27 divided by, so I'm going to invert and multiply, divided by 5/9. I'm going to think of that as times 9/5. Once again, notice that I get 1/3. So a couple of ways to get your R value. That's key in the lesson today. Now, watch how easy it is to come up with this sum now. I'm going to take g sub 1. The sum, as we go to infinity then, is going to be g sub 1 over 1 minus r. So I've got the sum as we go to infinity is going to be 5/3 divided by 1 minus 1/3, which becomes 2/3. You can run this through your calculator. And guys, just to remind you, if you're going to run that through your calculator, make sure you use parentheses properly. Meaning this, I'm going to go parenthesis 5 divided by 3 divided by parenthesis 2 divided by 3. Math enter in case it's an ugly decimal tells me this sum is going to be 5/2. So I'm going to come up here and say the sum as we go to infinity is going to approach 5/2. But the key thing there, guys, you got to make sure that it's geometric. So I'll use my calculator off and on as we go today. So jump over to your number 2 if you would. 1, it's a series, but now let's make sure that it's a geometric series. So I'm going to come over here. I'm going to take my second term divided by my first term, and I'm at 0.25. Now let's take your third term divided by your second term. Since they're the same, this thing is geometric. So my g sub 1 value is 640. My r value is 0.25. To get my answer, the sum as I go to infinity is going to be 640 over 1 minus 0.25. Make sure you put that in parentheses or do it in your head. And guys, if you run that through your calculator real fast, you should get an answer of 2,560 thirds. Get in the habit of going math enter with all your numbers just so that we can make it clean. Okay? So guys, that's our main formula today. G sub 1 over 1 minus r. Let's come over and look at your number 3. Step number 1, I got to ask myself, is it geometric? So I'm going to take the second term divided by the first term. And you can do this in your calculator. So I'm going to have 5/2 times 2 over 1. So far I'm at 5. Now let's take the third term divided by your second term, which is going to be 5/2. This really becomes 9/2 times 2/5. Notice that I don't get the same R value, so our formula does not work. We're going to put not geometric. And we're going to move on. We're done with that one. So do not use your formula unless it's purely geometric. Okay? Here comes number 4. This thing is automatically geometric. The reason I knew so fast is because I have something in parentheses to a power. And I don't have any pluses or minuses out here. So I know that my R value is 4/5. Now let's go get our G sub 1 value. So plug in 1 right there for n. 1 minus 1 is 0. 4/5 to the 0 is 1. 500 times 1 is 500. So my sum, I'm going to say that the sum as we go to infinity is going to be 500 over 1 minus R. I'm going to do this one in my head. 500 over 1/5 really means 500 times 5. So the sum as we go to infinity is going to be 2,500 in this case. Okay. So that's what we got so far. I'm going to hit a couple more with you, and then I'm going to switch gears just a little bit. Number 5, you got to decide if it's geometric. The way I attack it, I look and see if I could do it in my head from term to term. So what's it take to go from 4/3 to 8/3? I'd have to multiply by 2. To go from 8/3 to 16/3, I'd have to multiply by 2. So it is geometric, but this thing does not converge. And here's why. For this thing to converge, my R value's got to be between, or it's got to be less than 1. The absolute value of my R value's got to be less than 1. That way, guys, we're multiplying by a small fraction. And when we multiply by a small fraction, we get those decimals that you saw on my spreadsheet. So we're adding numbers that are smaller and smaller and smaller. So when your R value, absolute value, is not less than 1, it does not converge. This thing is going to grow forever. We could have also said that it's going to diverge. Okay? So I slipped a rule in. The only time that you can use this formula is if the absolute value of your R is less than 1. Okay? So if you would look over at number 6. It's definitely geometric. The reason I know, my R value is -3. But ask yourself this, is the absolute value of R less than 1? Absolute value of -3 is 3. 3 is definitely not less than 1. So even though this is geometric, it does not converge. So it does not have a limit. Really, what's it going to do? It's going to grow in the positive direction and the negative direction, because this thing's going to alternate. Okay? So guys, the main formula so far, G sub 1 over 1 minus R. Here's a couple more really fast. On my number 7, I got to ask myself, is it geometric? The answer is yes. How do I know that? I'm not adding or subtracting out here. And I've got a parenthesis to a power. So in this case, my R value is 1/2. Now let's go get G sub 1. So plug in a 1. 1/2 to the first is 1/2 times -2 is -1. So the sum as I go to infinity is going to be -1 over 1 minus 1/2, which is really -1 over 1/2. So that's going to be -2. So as we add those up, the sum as we go to infinity is going to be -2. So to properly write it, the sum as we approach infinity is going to be -2. So it worked on that one. Peek at number 8 real fast. I'll pause for about 10 seconds. See if you think that converges or diverges. It is geometric. So that's a for sure. But look at your R value. My R value is going to be 4/3. Ask yourself, is the absolute value of 4/3 less than 1? The answer is no. So this thing does not converge. Guys, what that means is as I add these up, it's going to grow forever. It's going to grow forever. Okay? So there's where we are so far. So the first part of our lesson just based on that formula right there. I'm going to continue to use that formula, but just in a little bit different. So hang with me on a few more here. It says, rewrite each of the repeating decimals as a sum of a finite decimal in a geometric series, and then decide if it converges or not. And then we're going to turn 0.7 into a decimal. Guys, if you know your nines, division of nines, 0.11111 is 1 9, 0.22222 is 2 9s, 0.33333 is 3 9ths, which reduces to 1/3. 0.7 is going to be 7 9ths. So I already know this answer is 7 9ths. Let me show you how to get it using geometric series formula. So hang with me here. I'm going to think of 0.7 repeating as 0.7777 on down the road. This thing has a 0 out front. So I'm going to have a 0 plus. Now here's where the trick comes in at. This is really 0.7 plus 0.07 plus 0.007, and I can do that forever. I got 0.7, and then to get to this 7, I need a 0.0107. To get to that one, I need a 0.007. Now guys, here's why I did this. My R value is going to be 0.07 divided by 0.7, which is 0.1. 0.07 divided by 0.7 is 0.1. Now I'm going to take the number out front. So I'm going to have 0 plus g sub 1, which is 0.7, over 1 minus 0.7. I'm sorry, 1 minus 0.1, my R value. So I've really got 0.7 over 0.9. Slide your decimal place over on each of them, aka multiply by 10. So there we have the fraction 7 9ths. If I confused you on that one, hang with me. It'll come clear really fast. And then guys, check this on your calculator real fast. 7 divided by 9, make sure you get back to 0.7's repeating. If you would, look over at number 2, because I should have confused you on number 9, so I meant number 10. The hard part is right here. I'm going to think of this as 2.51 repeating. I'm going to think of it as this. 2.51, 51, 51 forever. Now guys, ask yourself, what decimals are repeating? It's that 5-1 part. So picture this. I'm going to think of this as 2 plus. So I've taken care of this. Now I'm going to take in consideration what repeats. The 0.51. So guys, I've taken care of these two right here. Now, I need to now take care of these two. So I need 1, 2 zeros, and then a 5-1. So this 0.51 is taken care of right here. This 0.51 I took care of as 0.0051. Here's why I did all of this weird looking work. I did that so I could figure out my R value is 0.0051 over 0.51. Means my R value is 0.01. Now to get my answer, it's going to be that 2 that we had out front plus G sub 1, which is that first repeating decimal part, 0.51, over 1 minus 0.01. 1 minus 0.01. So there's where I am for a second. So this really becomes 2 plus 51 over 99, which isn't our answer. 2 plus 51 over 99, so 2 plus 51 over 99. So there's that decimal, so that looks good. Math, enter, enter. Here's my answer, 83/33. So there's 2 down. Let's come over to your number 11. So here goes. Write down the part that does not repeat. So I'm going to have 39.4. There's the part that does not repeat. Now let's add in the rest. To get to this 0.65 here, I need a 0 right there. So this becomes 0.065. Now, there's another 65 back here. So plus 0.00065. And then that's going to go forever. Why did I do that? I need my R value. So I'm going to go 0.00065 divided by 0.065, and I'm going to get an R value of 0.01. Guys, notice this while I'm here. 2 repeating decimals, 0.01. Let's come back here. 2 repeating decimals, my R value is 0.01. So now guys, to go get my answer, it's going to look like this. I'm going to have 39.4 plus 0.065 over 1 minus 0.01. Let's run that through our calculator now. So let's go 39.4 plus, if my calculator come back, 39.4 plus 0.065 divided by 1 minus 0.01. Enter. So look back up at the number, 39.4656565. Let's go math, enter, enter. So I've got this answer, 39,071 over 990. So there it is as a fraction. Guys, your calculator can do this for you, but things that we need to see, show us that you can write that out. Show us that you know the R value. Show us that you've applied the geometric series formula, and then let's go get it. Okay? I'm going to go ahead and skip number 12 with you so I can jump over to number 13. I'm hoping to keep my video at about 30 minutes. After that, it's hard to listen. So, if you would come over to your number 13. Kind of a famous problem, a puzzle problem. It says a famous infinite geometric series problem. In a circus, a jumping flea is at the center of a circular ring of radius 1 meter. So I know I've got a radius of 1 meter. Suppose the flea jumps along the radius towards the edge of the ring, but that each jump is half the length of the previous jump, because the flea gets tired. Suppose the flea's first jump is a ½ meter long. Write a sequence showing the lengths of the first 5 jumps. Well, so the lengths of the first 5 jumps. So the first one he jumps a half. The next one he jumps a fourth. The next jump he jumps an eighth. And then the tired flea jumps a 16th, and then a 32nd. So I tuck my 1 after the first jump. There's my 1/2. It says, what's the length of the flea's 8th jump? Well, guys, 2 ways. Do this 3 more times. You could do that 3 more times. Or we could go ahead and use our geometric sequence formula, which says 1/2 g sub 1 times my r value to the 8 minus 1 is 7. Run that through your calculator. Math, enter, enter. And it's 1 over 256th of a meter. So that's my part B. On part C then it says, how far was the flea from the center on the 8th jump? This is asking me to add up those first 8 terms. It's asking me to add up a half, a fourth, an eighth, a 16th. So I'm going to do this. The sum of these 8 jumps is going to be g sub 1 r to the 8th minus 1 all over r minus 1. So 1/2 minus 1. Okay. Run that through your calculator, and you should get 255 out of 256 of a meter. So he's pretty darn close. Pretty darn close. On part D, what's the smallest number of jumps that will get the flea within 0.001 of a meter of the edge of the ring? Well, guys, there's 2 ways to do this one. A little trial and error, and I'm going to show you a trick on the calculator. So let me bring my calculator back out. Let's type in that little formula that I just had there. So let me go 0.5 parenthesis 0.5 caret 8 minus 1 divided by my r value minus 1. So this is what we just did a second ago. So as a decimal, I'm at 0.996. I need to be within 0.001. So I need to make that say 0.999. So guys, I'm going to go second entry, and I'm going to come change this 8 to a 9, meaning my 9th jump. If I do that, now I'm at 0.998. So after the 9th jump, he's 0.998 of a meter. I'm not within 0.01 yet. Let me go second entry again, and let me change this 9 to a 10. So I'm going to go 10, and then I got to go minus 1, parenthesis, now I got to retype some things, divided by, parenthesis, 0.5 minus 1. So guys, boom, there's my 0.999 that I see. So on the 10th jump, he will be within 0.001 of a meter of getting out. I'm going to show you a calculator sequence here in just a heartbeat, though, for this. That's a little slicker than this. On part E, it says, will the flea ever reach the edge of the ring? Technically, no. He's going to get so darn close, we're going to say he does, but technically, mathematically, he never would. Now guys, let me show you a calculator sequence. You might have to pause the video and write this down as we go, but there's a way that the calculator can do this sum for us, especially on this trial and error to be within. So guys, if you would have your calculator in front of you for a second. I'll go slow on this part so that you can see it all. And then pause this video as we go and write it down, or write it down as soon as we're done. Guys, if you would, go second stat and come over to math. Second stat, come over to math, and come down to the word sum. Now, go second math, or second stat, over to operations, and come down to sequence. So if you're not following along with your calculator, write these down or pause the video. Guys, here's what I'm doing so far. I just told the calculator, I'm going to give you a sequence, and you're going to sum it up for me. So that's what we've done so far. Now, what you have to do is this. I need to type the formula in that I'm using. So I need to type this formula that I wanted to use. I need to type that sequence formula that I'm doing. So come over to, we had it right there. It's going to be 0.5 times 0.5 caret x minus 1. And I need that x minus 1 in parentheses. And then a comma. So guys, in the first blank, you type in your formula. And then you tell it in your second, after your first comma, tell it that we're using the variable x. That's going to be the case every time. Another comma. Tell it we're starting with the first jump. So there's a 1 now. And then another comma. Now what goes next is the number of jumps that you want it to sum up for you. So I'm going to type in 10, since we know that's the answer. And then it always ends in a 1. Okay. So guys, I'll do it on the next one also. So we went second stat, over to math, down to sum, second stat, operation sequence, and then what goes? Your formula, and then an x, a 1, the number of terms you want to sum up, and then a 1. And then guys, when you hit enter, there's that 0.999 number that we just had. Okay. I'm going to do it again on number 14 so you can see it again. So if you would guys, here's our last one. Come over to number 14, which says this: consider the harmonic sequence. Remember the harmonic sequence, guys? That's that one that went 1 over n. Rewrite the harmonic series in sigma notation. It's going to look like this. There's my sigma notation. N equal 1 to infinity of 1 over n. Now it says, use a calculator to find how many terms of the harmonic series must be added for the sum to exceed each of the following. So here goes again. Launch your calculator. And then remember, I'm going to go second stat, over to math, and I'm going to go down to sum. And then I'm going to go second stat, over to operations, and sequence. In the first spot goes the formula that we're using, which is 1 divided by x, comma, and x, every time, the formula that you're using, comma, a 1, because that's where we're starting. Now, here's the one that you'll change over and over and over. So we need to guess how many. So guys, for now, I'm going to type 5. It's just a guess. Comma, 1. Now remember, I'm trying to beat 2. So notice I'm at 2.28. Well, go second entry. Let's come up and change that 5 to a 4. So now I'm summing up the first 4 terms. And let's see what we got. 2.083. So I know on this one it's going to take 4 terms. And let's get rid of that 4th and put 4 terms. To get a sum greater than 5, have your calculator again. Go second entry. And let's change this to, I don't know, maybe 10. So I'm going to go 10, comma, 1, close that back off, enter, and I'm at 2.92. Well, remember on this one, guys, we are trying to beat 5. So second entry, let's change that 10 maybe to a 20. So it's a little bit of trial and error right here. So it looks like I'm at 3. Well, let's really bump it up. Let's go second entry, and let's go 50. 4.499. Well, now we're starting just to add more and more decimals. So let's try 80. 4.96. So now I know I'm getting close. So let's try 82, 83, 84, something like that. There, guys, I finally beat a sum of 5. So it's going to take 83 terms to get over 5. Okay? So it says true or false. The harmonic sequence is divergent. That's true because this thing's going to grow just a little bit forever. So guys, that is section 8-7. It's our last section in chapter 8. Good luck on the assignments. It's on OneNote unless you needed a paper copy. Good luck to you.